Welcome, dear students. Today we are going to study the first chapter of class 12th physics NCERT book. The name of the chapter is Electric Charges and Fields. My name is Dr. Gaurav Sinha and let's start this topic now. So let's start the topic. The first topic is electric charge. So let's try to know how and from where it was discovered. So the credit of discovery of electric charge goes to Thales of Miletus, and it was in Greece in the year 600 BC. So electric charge, we can we can we can try to understand, we can understand how the charge was discovered, how it was known to the humans in the history. First time it was discovered by a scientist from Thales of Miletus, Greece, in the year 600 BC, and the experiment was done to understand the property of charge and the charge. If we take a glass rod, suppose we have a glass rod, and this glass rod is suspended by a silk thread, and we have another glass rod. We bring this another glass rod near to the suspended glass rod, and if this first glass rod, this is, let us say, first glass rod, and this is second glass rod. So in this experiment, if we rub this first glass rod with a piece of silk or wool, so if we rubbed by silk or wool, then a positive charge will appear on the surface of the first glass rod. And if this second glass rod, this is also rubbed by silk, then again same thing will happen to this second glass rod, and positive charge will appear on the surface of second glass rod. Now these two glass rod will repel each other. So from this experiment we can understand the same charge, or you can say same polarity of charge, appears on the both the glass rods, and the same charges repel each other. Similarly, if we take a glass rod suspended by silk thread, not glass rod, this time we will take one plastic rod. Let us take one plastic rod. This is the plastic rod, and we rub this plastic rod, which is suspended with silk thread, we rub this plastic rod by cat's fur. Okay, rubbed by cat's fur. And similarly, so first time when we rub this with the cat's fur, we will see that there is a negative charge which will appear on the surface of the plastic rod. And if we bring another plastic rod rubbed by same cat's fur near to this first rod, then again the same thing will be repeated. These two rods will repel each other. Now from these two experiments, this is here I will write plastic rod. So from these two experiment, we can gain the knowledge. We can have this conclusion. We can conclude that same polarity charges always repel each other. So there are two polarities, or there are two types of charges. One is known as positive charge and another is known as negative charge. And from this experiment, which was done in the Greece, it was concluded, it was observed that a charge is developed, or a body is charged when it is rubbed with some another material. Glass rod, if it is rubbed by silk or wool, then it gets positive charged. It is positively charged. And if another glass rod rubbed with silk or wool is brought closer to the first rod, then both rod will repel each other. So we can conclude same polarity charges always repel each other. So positive charge will repel positive charge. Similarly, negative charge will repel negative charge. In the second case, there is a plastic rod instead of glass rod, and plastic rod is rubbed by cat's fur, not by silk or wool. It is rubbed by cat's fur. So negative charge appears on the plastic rod, and both these rods will repel each other. So this is how a body can be charged or electrified. Now in this third case, we have one glass rod rubbed by silk or wool, rubbed by silk or wool. And if we bring another plastic rod, if we bring one plastic rod which is rubbed by cat's fur, obviously the surface of this plastic rod, it will be negatively charged. This is negatively charged, this is positively charged. So now instead of repelling, these two rods will attract. This suspended rod will try to attract this, or you can say this plastic rod will attract this suspended glass rod. So here we can say that opposite charges, we can conclude that opposite charges will always attract each other. So all the three cases we have seen. First case, the two glass rods which are positively charged, so they will repel because they are having same polarity. Second case, we have seen two plastic rods which are negatively charged, and they will also repel each other because they have same polarity, both are negative. Third case, we have one glass rod, second is plastic rod. Glass rod rubbed by silk, wool, and plastic rod rubbed by fur. So positively charged, this tube will be attracted towards plastic rod because plastic rod is negatively charged. So opposite polarity charges will always attract each other. Now we will try to understand one phenomena where we have observed that some charged bodies, or you can say some glass rod which is positively charged, it will attract these small bits of paper. How it happens? Because bits of paper are not negatively charged. Glass rod, let us say it is positively charged, but bits of paper, they don't have any charge. Then how they get attracted? So we will see this under this topic, charging by induction. Charging by induction refers to inducing a charge. When a charged body comes closer to another uncharged body, then the uncharged body will will get induced charge, will be charged, will be induced, will get induced charge. Suppose we have two spheres, metallic spheres, let us say A and B, and they are mounted on, let us say there is a stand, insulated stand. This is insulated stand, insulated stand. Same stand we have used for the B sphere, metallic sphere. Now in these two metallic sphere, there is a particular distance in between them. If we bring a glass rod which is positively charged, okay, if we bring this glass rod which is positively charged closer to this metal sphere A, then the left surface of this metal sphere will will produce or will induce negative charge. So left surface will be having negative charge induced, because all negative charge of this sphere will be attracted by the positive charge of glass rod. So all the negative charge which was, inside this metal sphere will shift towards the left side. And because this is the positive charge, negative charge is on the left surface, the positive charge of this metal sphere, as well as this metal sphere, it will be shifted towards the right side. So this is the negative charge on left surface, this is the positive charge on right surface. Again, this is the negative charge on left surface and positive charge on the right surface. Now if I remove this glass rod, then suppose the two metal spheres A and B, they are brought closer to each other and they are in contact with each other. Now what is going to happen? See, glass rod is still there. Glass rod is still there. Now the two metal spheres are in contact with each other. Now this left surface will be negative and this right surface of B sphere will be positive. Because now both are in contact, so they will behave like a single body. They will behave like a single body because they are in contact. All the negative charge of both sphere will shift in the left direction, and all the positive charge of both sphere will shift in the right direction. So this is called as induced charge. Without touching this glass rod, without touching the glass rod with the spheres, the sphere has been charged, sphere has been electrified. Now this negative charge, this positive charge, once we remove this, once this glass rod is removed, this charge will again be uniformly distributed. Glass rod is removed, and again there is some distance between the two metal sphere A and B. So this negative charge will be uniformly distributed, and positive charge will also get uniformly distributed in metal sphere B. So this is called as charging by induction. So without bringing in contact this glass rod, we have induced charge, negative charge on metal sphere A and positive charge on metal sphere B. There is one more thing which in this lecture we will see: earthing. Now suppose one of this metal sphere I have taken here, again this positively charged metal sphere. If suppose this sphere is connected with the ground using some wire, is connected with ground using some wire, then the excess charge on this sphere will be transferred to the ground, causing a current, causing a momentarily current. In house we have seen we are using electrical appliances, or electrical appliances, all electrical appliances, they have a wire which is called as earthing wire. So in case of any electrical hike in spike in voltage, then whatever extra charge is there on the body of the appliance, that charge is transferred to the earth using the earthing wire. Now the procedure for earthing is, we use a thick metal plate, that is buried deep in the earth, and a thick wire, we have to use, always remember, we have to use a thick wire, is drawn from the metal plate and is brought near the main supply, So this thick wire which we have brought near the main supply, this thick wire will be brought into our house through the wiring, and it will be connected to the body of all the electrical appliances. Now we will see the difference between insulators and conductors. Conductors are those substances which readily passes the current through it. So I can write here the definition. Conductors, which, these are the substances which readily passes current through it. For example, like all the metals, they are good conductors of electricity, because we know that if you have a copper wire or some aluminum wire, you might have seen in your house in the wiring circuits that we use copper wire and aluminum wire, because they are good conductors of electricity, and they will pass the electricity through it. Metals, humans and animals body are good conductors of electricity. Earth, etc. On the other hand, insulators are bad conductors of electricity. So these are material which does not passes current through it. There are many substances which does not allow current to pass through it. Example, glass, basically all non-metals. Glass is there, silk is also a bad conductor of electricity, porcelain is a bad conductor of electricity, rubber, wood, paper, and other examples are also there, like we have plastic. So these are some material which does not allow electricity to pass through them. So such kind of materials comes under insulators, and the materials which allow electricity to pass through them are called conductors. We have understood there are two types of charges. Let us summarize. There are two types of charges. Positive charge. We have seen the example when glass rod is rubbed by a silk or wool, then the glass rod is positively charged. And on the other side, the silk piece is gets negatively charged. You can write here example, glass rod rubbed by a silk cloth. So glass rod will be positive charged. Negative charged, when you rub the glass rod by silk gets negative charge. So silk is negatively charged. Similarly, if I talk about a plastic rod, this is one example, this is second example. Plastic rod rubbed by fur. So plastic rod is negatively charged. It will be negatively charged. Here same example, second we can write here also. The fur which is used for rubbing the plastic rod, the fur is the fur gets positively charged. One important point here to note is that the positive charge appears on the glass rod which is being rubbed by silk, and on the fur which is used for rubbing the plastic rod. So we know opposite charges attract each other. So this glass rod, whether it will attract this plastic rod or not, yes, this glass rod will attract the plastic rod because glass rod is positively charged and plastic rod is negatively charged. Similarly, this fur which is positively charged, it will attract silk which is negatively charged. Silk is negatively charged. So these two will attract each other. These two will attract each other. These two will repel each other. These two will repel each other. Same charges repel each other. Opposite charges attract each other. So in the first column, whatever substances we have, they will attract the second column substances, and the substance in the same column will repel each other. Substance in the same column will repel each other. Glass rod will repel the fur, which is used for charging the plastic rod. Silk will repel the plastic rod. Silk is used for rubbing the glass rod. Silk will repel the plastic rod. So this is the types of charges which we have studied. Now we will see some properties of charge. Properties, there are three properties. First one is additivity of charges. In this property, the charges, whether they are 2 charge, whether they are 4 charge, whether they are 5 charge, if you want to calculate the total charge of any system, then you can algebraically add all the charges of the system. Suppose we have a system in which we have 2-point charge, very small. Point charge means very small. We have 2-point charge. We want to calculate the total charge of this system, then we can algebraically add both the charges to calculate the total charge. So the total charge will be equal to algebraic sum of these two charges. If we have more than 2 charge, let us say we have n charges, n number of charges. There are n number of charges. Then to calculate the total, we can add all the n charges. So algebraic sum of all the individual charges will give you the total charge of the system. Second property is charge is conserved. Charge is conserved. Charge is conserved means charge can neither be created nor be destroyed. So whatever total amount of charge which is present in a system, it will always remain as it is if it is an isolated system. So in any isolated system, the total charge remains conserved. Charge will not be lost. Charge will remain as it is. It will neither be created nor be destroyed, or you can say charge will neither increase nor decrease if it is an isolated system. Because we know every body, every material, it has some charge, but that charge is equally distributed and it is equally opposite. Suppose there is a body, it is isolated body, okay, So we can say it is electrically neutral. Electrically neutral means total positive charge inside the body is equal to total negative charge inside the body. Similarly, in a human body, the total positive charge is equal to total negative charge. So we can say the positive charge balance negative charge. So body is electrically neutral. There is no excess charge on the body. All the positive charge will balance all the negative charge. So we call electrically neutral. Then there is a question which you might ask, then how current flows? So if there is a wire, electrical wire, and if it is connected with external battery or external some source which can produce the uh, which can force the charge through the wire, then current is produced in the wire. Otherwise, if it is isolated, there is no voltage or external source of energy connected with it, then it will remain neutral. If a human body, if we come in contact with a wire carrying current, then we get a shock, because our body, human body, is a good conductor of electricity, and the excess charge which is flowing through the wire, that charge will pass through our body and we will get an electric shock. Next property is quantization of charge. So quantization means that whatever charge is present in any body, that is some integer number, or you can say that is the integer multiply of fundamental unit of charge. So the total charge will always be quantized. Now here let me explain what is this fundamental charge. Fundamental charge. Fundamental charge is represented or denoted by E, and its value is 1.6 into 10 raised to the power minus 19 coulomb, because the unit in the international system which we know which is known to us as SI, international system of units is called SI system of units. So SI unit of charge is coulomb. E refers to charge of an electron or proton. So the smallest quantity of charge is E, and E is equal to charge of an electron or proton. We know that electron is a negative charge particle and proton is a positive charge particle. So charge on electron is equal to minus E. So we will put minus because it is negatively charged. Charge on proton is plus E because proton is positively charged. So this is the smallest charge which is present or which is defined in the physics. or in the physical world. In the physical world, the smallest charge is E, which is equal to charge of an electron or charge of a proton. In case of electron, it will be a minus sign because it is negatively charged. In case of proton, the charge will be with positive sign because it is a positively charged particle. Now, charged on the body, charge on any body is written in terms of fundamental charge. So fundamental charge is denoted by E. So charge on any body will be N into E, where N is integer. Where N is an integer. So this is called quantization of charges. Quantization means it will be integer multiple of fundamental charge, which is the smallest possible value of charge. The smallest possible value of charge is 1.6 into 10 raised to the power minus 19 coulomb. And any body which is charged, electrically charged, the total charge of the body will be some integer multiplied by the fundamental unit of charge. Suppose there is a human body, and if the human body is electrically given some charge. So if it is charged, then the total charge on the human body will also be equal to N multiplied by E, where N can be any integer. N will depend upon the number of electrons which are used or number of protons which are used or which are transferred to the body. Any body is charged electrically by transferring positive charge or by transferring negative charge. So whatever total charge is transferred, whether positive or negative, that charge can be calculated, can be represented in the form of N multiplied by E. N is number of electrons transferred while charging, or N can be number of protons transferred to the body while charging. So total charge will be given by this formula, Q is equal to N multiplied by E, where N is the integer or you can say number of electrons or number of protons transferred to the body, and E is the charge of one electron or one proton, which is the smallest possible value of charge. So thank you so much. That's all for today's lecture. If you liked the video, then please follow and subscribe the channel for more videos. Thank you.